All right, so it is 10 and we will get started for today. So just a brief announcement to begin with. Next week, Friday, and let me turn off the waiting room. So next week, Friday is your first test, the 19th. So just to make you aware of that, it is coming up soon. So please make sure you're going through and reviewing everything we do in class, making sure you're trying those problems. You can do all those problems, going back on Blackboard, looking at my previous tests, looking at my extra practice problems, going to SI sessions, whatever you need to do to get those reps in, get that practice in for the test that's coming up next week, Friday. All right. So what we are talking about today is that we are going to learn how to name molecules. And we're going to go systematically through basically every single combination of molecule we're going to see in Gen Chem 1 and learn how to name them. So the first thing we're going to look at is naming ionic compounds. Remember, an ionic compound is between a metal, which is shown on the left side of the periodic table, and a non-metal, which is shown on the right-hand side of the periodic table. So the first step is just determining, do I have an ionic compound? So don't forget that. Metal plus non-metal makes ionic compound. And then, based on what type of metal you have two ways to name it. So if your metal only forms one type of ion, you name it one way. And if your metal forms multiple types of ions, you name it another way. And so you might be asking yourself, what types of ions only have one charge, right? And we talked about this before. So any metal in the first column, they can only form a +1 cation. Anything in the second column can only form a +2 ion. Sc forms a +3 ion. Aluminum +3. Zinc +2. Silver +1. So you have everything in column 1, everything in column 2, Sc, then Al, Zn, Ag. Every other metal forms more than one type of ion. So when we're looking at ionic compounds, what type of metal you have will determine how we name things. And if you have a compound that's a binary compound, and so the word binary just basically means like two. Basically, it's just made out of two elements. So it can have more than two atoms in it, but by binary compound, we mean just one metal, one type of metal, and one type of non-metal. And the way you name a binary ionic compound with a metal that only has one type of cation, it's the name of the metal plus the name of the non-metal, and you just change the ending of the non-metal to "ide." For example, sodium's our metal here. Chlorine is our non-metal. We change chlorine to chloride for sodium chloride. Potassium, chlorine becomes potassium chloride. Calcium, oxygen becomes calcium oxide. So here are some common nonmetals that you'll use. And it's basically, just add ide to it. So fluorine, fluoride, bromide, iodide, sulfide, so on and so forth. In the metal, you just name the metal. So to begin with, we're going to do some practice on not only getting what compound we're making, but the name of each compound. So for this, I will do A to begin with. And then I will give people plenty of time to work through these because I do have a lot of examples. I do want to give people ample time to work on these examples. But let's do A. If I'm going to make a compound between calcium and oxygen, what is the formula of that compound? All right. So I hope everybody has their periodic table out or is looking at a periodic table somehow, or else this is going to be very, very hard. So the thing we need to do is find calcium. Calcium's element 20. This is in the second column. And we said anything in the second column forms a +2 cation. So calcium +2. Oxygen is in row 6A, element 8. And oxygen, when it's in a compound, 99% of the time forms a -2 ion. Now, we talked about this last week, but when forming an ionic compound, you have to make sure your cation and your anion, when combined, make a neutral compound. For calcium and oxygen, it's easy. Calcium's +2, oxygen's -2. You combine those two together in a 1-to-1 ratio, and the charges equal 0. So the element here is just CaO. So for A, B, C, and D, you're trying to combine the cations and anions in such a way that they are neutral, that when combined, they are neutral. Then for E, F, G, and H, you're going to do the naming scheme like we just talked about. So I'll give everybody some time to do this. If you have questions about this or you want to check your answers or anything like that, please let me know in the chat. Otherwise, let's get to work. So let me go over B in case you're still not quite sure you have it. Just give you another example. So aluminum is one of our special cases that we just kind of have to know what the charge is. And aluminum in a reaction will always form +3. Sulfur is right below oxygen. So since it's right below oxygen, it gets the same charge in a compound. Sulfur is like always -2. And the question is, when I combine aluminum and sulfur together, what ratio do I need to combine them in to be neutral? Right? Because if I combine them in a 1-to-1 ratio, +3 -2 equals +1. So really the math is if aluminum is 3 and I have X amount of them, and sulfur is 2 -2 and I have Y amount of them, what is X and Y so that this equals 0? And one easy way you can do this is that when you have different charges like this, you just cross multiply. What I mean by that is if aluminum's +3 and sulfur is -2, well, if I have 2 aluminum and 3 sulfur, that will equal 0. Because 3 times 2 is a +6. -2 times 3 is a -6. So 6 minus 6 equals 0. So hopefully that shows you, a little more complicated scenario. So I'm going to go back to letting you continue to work. Again, as always, questions or you want to check your answers, please let me know. All right. So since there's no questions, I'm going to assume people more or less get this, but let's go over this quickly then. So silver is one of those ones we have to know. Silver is Ag +1. Chlorine, halogen, -1. Halogens are always -1, so that's AgCl. Silver chloride. Aluminum, we did in B, is +3. Fluorine, -1 halogen. So this is AlF3. And sorry, my pen's not working, so I'm trying to use my mouse as best as I can for these. So ELF. All right, name each compound then. So all of these are metals: magnesium, potassium, copper, and lithium. All of them are metals that only have one type of charge. So on the test, just be aware that, this will be mixed up. I'm not going to be obvious and say this metal only has one type of charge. This is something that you need to learn. So make sure you know which metals have one type of charge by looking at the periodic table. Anyways, E, magnesium nitride. So just name the metal, then nonmetal plus ide. F, potassium fluoride. G, copper iodide. H, lithium sulfide. So the naming, as long as it's only one type of ion, I think it's pretty straightforward. But are there any questions about anything presented here that people might have? All right, if not, we can move forward. Looks like we do. So numbers don't matter yet when naming. They do not. Numbers only matter. We'll see when numbers matters. Numbers matter with metals that have multiple charges. Could you repeat the name for the compound? Sure. Magnesium nitride. Potassium fluoride. Copper iodide. Lithium sulfide. So again, for questions E through H, we just add I to the end of nonmetals. Yeah, as long as the metal with only one charge, the name's super easy. It's metal plus nonmetal ide. Where it gets more complicated is where we're going. So this is the easiest type of naming we have in all chemistry, in my opinion. Are the charges described in the book? Probably. It's also on this slide. Column 1 + 1, column 2 + 2. Aluminum, zinc, silver, 3, 2, 1. Scandium, 3. Or scandium, not scantium. Yeah, but they should be in the book, and we did talk about them last week as well. So hopefully this repetition is starting to hammer what those are. All right. Let's get a little more complicated. Now let's name binary ionic compounds. Again, one type of metal, one type of nonmetal. But this time, metals have more than one type of charge. So previously, we were working with metals that only have one charge. Now we're going to work with metals that have multiple charges. And the only difference here is that you have to tell me what the charge of the metal is using parentheses and Roman numerals. So here we have like iron with a 2+ charge, that's iron 2. Iron with a 3+ charge, iron 3. And basically, and I'm just going to go back here now, anything on this periodic table that's not in column 1, not in column 2, not scandium, not aluminum, zinc, or silver. If you're a metal and not one of those, you have multiple charges. we have to know what type of metals have one charge and what type of metals have more than one. Yes. Luckily, it's easy because at least I think it's easy because it's column 1, column 2, then Scandinavium, aluminum, zinc, silver. So there's only 4 that fall outside of column 1, column 2. If you just remember all of column 1, all of column 2, and those 4, you have it. Right. And so here, chromium with a 3+ charge is chromium 3. Then to make it neutral with bromine, remember bromine's -1 because it's a halogen. We would need 3 bromine for every 1 chromium, and it's called chromium 3 bromide. Same thing with copper. Copper with a 2+ charge is copper 2. Oxygen has a -2 charge. So that's a 1-to-1 ratio. So it's called copper 2 oxide. Note that when it comes test time, I see this every year. If you try to use a metal with a set charge and you use a Roman numeral, that is wrong. Like calcium oxide is not calcium 2 oxide. That is the wrong name. So you will be dinged for that. So make sure you know the proper naming scheme based on the metal that we are using. And of course, we have practice for this. So I have 4 compounds here, and I even make it easy on you to show you what type of charges these metals could have, but we don't really need that. And I'll show you in A why you don't need that at all. So A, we have iron and oxygen. The reason why we don't need the chart on the right is because nonmetals will have set charges. Nonmetals always have set charges. So oxygen always has a -2 charge. Always, well, 99% of the time. There are examples where it doesn't. We're not going to worry about those. So we're going to say in Gen Chem 1, anytime you see an oxygen in a compound, it's -2, right? So the math here is I have 2 irons, but I don't know their charges. So that's X minus the charge of oxygen, which is 2, and I have 3 of those. And in total, their charges have to be neutral because they're an ionic compound. So solve for X. 2 times X minus 6 equals 0. Well, X must be plus 3. So the name for this, and so I'm going to try to use my pen even though it's really wonky, is iron 3, so Roman numeral 3, oxide. So see if you can follow that logic and name B, C, and D. I will say for C that should not be a capital L. That's a lowercase l. It's a lowercase l right there. But yeah, try B, C, and D. If you have questions, please let me know. And as always during this time, I do hope you're working on these instead of waiting for me to give you the answer. Because if you're just waiting and not asking questions, usually those students don't do well on the test. So it's really putting in the reps, asking if you're confused, reaching out. That's how you become stronger in this subject or any subject really. So let's take a look at this then. So sulfur is right below oxygen on the periodic table, element 16. And so it has the same charge as oxygen, -2. And we have 3 of these. So it's going to be the same math as we did in A. So chromium must have the same charge, +3. And so this, let me get my janky pen back out as best as I can. Chromium 3 sulfide. And then for C, chlorine is -1, and we have 3 of those. So iron must be +3 to make that a neutral compound. So just like in A, we have the same type of iron. So this is iron 3 chloride. And then in D, we always multiply across when it's ionic compound. Yeah, because you're trying to make a neutral compound. So basically what this is that once you know the charge of the anion and you know how many cations you have, you can do that multiplying across. Or you can set up the math like I did in A, whatever is easier for you. But yeah, so for D, iodine's -1. We have 4 of those. So lead must be +4 to make a neutral compound. So this would be lead 4 iodide. You thought iron had a +3 charge already? Iron can have a +3 or a +2. So we have to figure out what it is. Iron is not set, so we have to say what it is. Yep, so that's lead 4. Yep, IV. Yeah, for all metals that have more than one charge. So let me tell you why we have to do this. So imagine that we lived in a world where we didn't have this naming scheme. And I was talking to another chemist and I said, I'm working with iron chloride, or I need to do an experiment. Please buy me iron chloride. Well, is this person going to buy me FeCl2 or FeCl3? Because if we don't have the Roman numeral system, technically they're both iron chloride, right? This is iron 2 and this is iron 3. However, luckily we do live in the world where we have this Roman numeral system. So that's why we need to use these Roman numerals to be distinctive about the metals we use. So it doesn't matter what the charge of the metal is. It does. Because in all those examples, I'm telling you what the charge of the metal is. That's what the Roman numeral says. Right? So if I go back to this example, this is iron 2 chloride. Oh, doing this with the mouse is super hard. That's iron 2 chloride. This one's iron 3. That Roman numeral says what is the charge of the cation. All right, any other questions about naming compounds with metals with more than one charge. So we will be given what ion the metal, no. If you're saying you'll be given like a chart like this on the right, you won't, right? That's why I keep saying, like, make sure you know that group 1 always has a +1. Group 2 always has a +2. Scandium has a +3. Aluminum, zinc, silver, 3, 2, 1. If it's not one of those metals, you have to figure out the charge. I will not be providing a table like this. And that's why we also did on this question, why I showed you how to figure it out if I gave you just the compound. You can figure out the charge because the nonmetals always have fixed charges. And I'm going to go back to this periodic table. Although it's not listed here, right? This column always has -1. This column, for the molecules we're going to look at is -2. Nitrogen, if it's in one of these, will be -3, but nitrogen's weird. But mostly, when we're talking about binary compounds, binary ionic compounds, we usually just use these metals, or nonmetals, rather, sometimes nitrogen. But usually it's those. So as long as we know those charges, we can figure out the charge of any other metal. How do we know iron is +2 or +3? Well, so go back to our example, right? So if I go to A, right, I know that oxygen's -2 because what we just talked about, oxygen's always -2. And so the math is I have 2 irons, but I don't know their charges. So 2 times X. I know the charge of oxygen, it's -2, so I put a -2 there. I have 3 of those. So this ionic compound, when all the charges are added together, must equal 0. So 2x minus 6 equals 0. And 6 is the charge of the iron. So iron must be +3. Same thing for C, right? I have 1x, so I have 1 iron, minus 1. That 1 is coming from the charge of chlorine. Chlorine's always -1. I have 3 of those. When I add a metal and a nonmetal together, they must equal 0. So this math is x minus 3 equals 0. So what's x? X must be +3. That's all I'm doing in A, B, C, and D. So that's where the cross multiplying comes into play to figure out charges. Yeah, right. I'm just showing you how to do it algebraically. You understand now? That's what I like to hear. All right, moving on then. Now comes the difficult part. The first 2, rather simple once you get it. The difficult part comes with Oxy Anions, because Oxy Anions have names that don't make that much intuitive sense. If you remember polyatomic ions, then that's what I should have been saying instead of Oxy Anions. But we're going to learn how to name polyatomic ions. A polyatomic ion is an anion made of multiple atoms. So here, for example, we have acetate, 2 carbons, 3 hydrogens, 2 oxygens. Overall, that whole compound has a charge of -1. And a lot of these are Oxy Ion Anions, which just mean they have oxygen in it. And there's some logic to this. So if we look at compounds that have like the same anion on it, so here we have 4 compounds that have chlorine and oxygen, and they all have a -1 charge. Their naming scheme goes, the thing with the lowest oxygen, we call that hypochlorite. Hypo means below, right? A hypodermic needle is a needle that goes below your skin. So the word hypochlorite means I have less oxygens than chlorite. Well, chlorite means I have 2 oxygens. Chlorate means I have 3 oxygens. And then perchlorate, per means above. That's what the prefix per means. So perchlorate means I'm above chlorate, or I have 1 more oxygen than chlorate. Not the greatest, I know. A lot of these, like, how would you ever know ammonia's NH4 from this? So why is the first one not called acetate when there's only 2 oxygens? Yeah, because this doesn't have a good system. A lot of these names were created before the IUPAC system. So IUPAC is like the International Council of Naming Molecules. And so I don't know when IUPAC was formed. It was like in the 50s. So in the 50s, since then, a bunch of scientists have gathered around and said, let's make molecule names make sense. Let's have them follow a formula. While before that, whoever discovered the element could name it whatever they want. That's why you get weird names like this, right? That don't follow a pattern. So like ammonia doesn't really follow a pattern. Acetate doesn't follow a pattern. Sulfite doesn't follow the 3 and the 2 oxygens really. So cyanide, right, doesn't really follow a pattern, or peroxide. So yeah, the names are horrible for polyatomic ions, unfortunately. So I don't have a good system to really learn these other than pure memorization. Everybody's favorite brute force memorization. So what I did when I was a student to learn these, I created flashcards, my favorite. And I would carry these flashcards around my backpack. And when I was walking between classes, or if I was having lunch, I'll pull them out, do a set of like 5 to 10 minutes, put them back. Do that for a week, you will have this memorized. So on the tests, you should have all these memorized. That is my goal for you. I'm sure there's apps to do it, but I would honestly do the old-fashioned flashcards. Or, so what I have on my phone, so one of my hobbies, weirdly enough, is learning foreign languages. And so I have a flashcard app that costs me 99 cents. And it's great because you can set it up in such a way where, like, if you get something right, it'll be like 20 hours till you show it again. If you get it right again, it'll be like, okay, I'm not going to show you this for 2 days. And then if you get it wrong immediately, you'll be like, well, you don't know it actually. So I'm going to show this again to you in like 5 hours. But yeah, pure memorization, everyone's favorite term. The names are what the prefixes and the ending means, like how many oxygens they have in the chart. So what you should be able to do, come test time. If I show you acetate, you should be able to tell me what the formula acetate is. Or if I show you the formula of acetate, you should be able to tell me what the name is. You should be able to go both ways. It's only 1, 2, 3, 4, 5, 6, 7, 8. It's only what, 22? That's not bad. You can memorize 22 things. I have faith that if you got into college, and if I know high school is a lot of memorization. Because I remember having to memorize words for vocabulary. And those lists were bigger than 20 words. So I have faith people in this class can memorize 22 things for me. I believe in you. Your high school was 24 years ago? Well, time to get working on those muscles again. All right. So what we're going to do is I have a bunch of metals here for you and a bunch of nonmetals together in an ionic compound. Please tell me the names of those ionic compounds. I will do A, and then for the rest of the time, I'll let you do B, C, and D. And then on Wednesday, we're going to pick this up. I assume this would take us some time to do, so that is perfectly acceptable. All right. So the first thing we have to do, and in these, I have mixed up the metals. So the first thing you need to do is figure out if the metal has a fixed charge or not. So Cu is copper. Copper's element 29. That does not have a fixed charge. It's right in the middle of the periodic table. So that means I have to use Roman numerals because it does not have a fixed charge. NO2 is nitrite. Nitrite has a -1 charge, right? So if I have one copper and one nitrite, and nitrite is -1, my copper must be +1 to equal out. And then naming it is copper, then Roman numeral 1, because like we said, this is a metal that has multiple charges. Copper 1 nitrate or nitrite. All right, so the naming scheme, the way we handle the metals is the same. All that's different now is that we have weird names for our polyatomic ions. So let's see if we can follow that for B, C, and D. We don't worry about how many oxygens are on that compound. We do, right? So I'm looking at the nonmetal. It's NO2. And here, I have the list for you because nobody has it memorized yet. So I'm just looking on this list for NO2, NO2, NO2. And NO2 means nitrite. So this compound is called a nitrite. So that's why this name is copper 1 nitrite. If this was NO3, I would call it copper 1 nitrate. So the oxygens do matter because that's how we name stuff. And that's how I knew it was a -1 charge, because it says right here it's -1. Yep. I will say, those of you who have the dreams and hopes of seeing me in biochemistry 1 in 2 years or whatever, doing this right now will save you time, because the first thing I have my students in biochem 1 do is I have them memorize this table. That's like day 1. Here's this table again, plus like 15 others. Make sure you know all of these. So you will be seeing these again if you move on in chemistry. Those of you who are at the live session or watching on YouTube, you are a leg up on all your classmates who do not watch the videos, because they won't know to memorize these. So congratulations. Thank you for putting in the effort. The ite on the end of nitrate is the number of oxygens in that compound. It is. So nitrite and nitrate follow the ite and the ate. So it does chlorite and chlorate. But that's not a hard and fast rule. 2 oxygens does not always mean that it ends in ite. Like peroxide ends in ide, even though it has 2 oxygens. So it's confusing. Blame old-time scientist. So it depends on the contents of the compound. Yeah, exactly. All right, so time's running out. So let's look at these. So B, we have magnesium, Mg. Mg's in column 2. So column 2 things always have a +2. That means no Roman numerals. So I know the first part of this name is just going to be magnesium. Right? And then I look at my anion, C2H3O2. Well, that's acetate. So this is simply magnesium acetate. So I did get a question, should we add like di to acetate to make it diacetate? And the di, tri stuff that I talked about in the videos, those are only for covalent compounds, and we'll be going over that like on Wednesday. So for ionic compounds, the only special thing we do is if we do our numbering system. Okay, C is barium. Barium's also in the second column, so it's also +2. And since it's in the second column, we know its charge. So I don't have to specify its charge in its name. Again, I'll just go over the logic for this. Since barium's always a +2, if I tell a scientist I'm working with barium and this is nitrate, because NO3 is nitrate, they know the molecular formula already. They know barium is +2. So if I say barium nitrate, they know I must need 2 nitrate molecules to make it even or neutral. While if I'm working with copper, copper can be 1 or it could be 2. So if I just said to a scientist, I'm working with copper nitrate, they don't know if I'm working with copper 1 or copper 2 from if I don't say the Roman numeral. So that's why we need to say the Roman numeral to tell people what we're working with. Will it be wrong if we do put the Roman numerals? Yes. Magnesium 2 acetate is not the molecule. It's magnesium acetate. You can't put Roman numerals on everything. Correct. On C, does it matter that NO3 is in a parentheses, there's 2 on the outside? Yes. So this 2 is saying I have 2 molecules of the parentheses. So this is saying I have 2 molecules of nitrate. It doesn't matter in the name. It's just, it matters in the actual formula, right? Yeah, so the 2 on the outside doesn't matter when it comes to naming. It's just saying our compound is this. All right. And so for D, we have iron, Fe. Iron's in the middle, so I don't know its charge. It can have multiple charges. So that's why I wrote that wonky question mark. OH is hydroxide. Hydroxide has a -1 charge. I have 3 of them. So doing my math, if iron is an unknown X minus 1, which is hydroxide, times how many hydroxides I have, 3, x minus 3 equals 0 because it's a neutral compound. X must be plus 3. So this compound is iron, and I'm not right at the top because my pen actually can't go that far down. Iron 3 hydroxide. Right? So when it comes to these polyatomic ions, and if you're an ionic compound, the only thing that is different compared to question 1 and question 2 is naming these compounds, right? Here they have non-standard names. We just have to know those. But naming the first part, the metal, is the same as in question 1 or in question 2. All right, so is there any other questions people have about this now that you've seen the answers? Does exam 1 cover chapters 1 and 3 and part of chapter 4? I think it does. Basically, I don't know the exact chapters off the top of my head. I just know which dates I go to. So the end of Friday, this Friday, is basically the end of chapter 1 or test 1 material. So whatever we cover on Friday, that's going to be our last material. All right. So that's all the time we have. Yep. Session today at 2 for SI for more naming stuff. So will next week be review? No. Oh, that would be nice if I could dedicate a whole week to test review. Next week's all new material for test 2. Unfortunately, I do not have time to review stuff. We have to get through a lot of stuff on chemistry. So it's going to be keep it chugging. Is the exam date on the syllabus? Yes. All my exam dates should be on the syllabus. I think they're all on Fridays, except maybe the last one. Okay. So with that, I will put a homework up. I will see if I can't get more example problems for these. Otherwise, hope this was clear. If you have questions, let us know. Otherwise, have a good rest of your Monday. Take care.